evolutionary process going on. But mankind won't be destroyed. The fact that you and I are working here today is evidence of that. Evolutionary process going on. But mankind won't be destroyed. The fact that you and I are working here today is evidence of that. and I are working here today is evidence of that. But mankind won't be destroyed. The fact that you and I are working here today is evidence of that.
Good evening, one and all connected here. I immense pleasure to welcome our Honorable Chairman, respected Vice Chairman, beloved Principal, Head of the Departments, Admission Director, faculty members and participants. It is an incredible privilege and honor for me to welcome our prestigious Chief Guest, Shri VSS Sastry Sir, who is the Science Communicator from Karnataka. Welcome you, sir.
Thank you.
We also render our hearty welcome to Dr. Rajesh Kumar Thakur, sir, who is the Secretary of All India Ramanujam Mathematics Club. Welcome you, sir. I extend my heartily welcome to Shri Kannabaran, sir, Coordinator to Galileo Science Club. I welcome you, sir. Once again, I welcome you all for the second day of the webinar series, Experiential Learning of Science, jointly organized by Janssen Institute of Technology and the Galileo Science Club. Now I welcome Sir to felicitate the gathering.
Okay, thank you very much. Good evening to all. So it is my privilege to be here. Basically, I am a team member, co-team member of All India Ramanujan Maths Club that has been working for the betterment of the children for the last 25 years, since its inception in 1993 in Gujarat. So All India Ramanujan Maths Club is presently working in more than 20 states. So in the last year, Ramanujan, for the last 25 years that I told you that we were working for the downtrodden children, especially we were invited in the small villages and we were working freely. Means in the month of May and June when I was free, so I used to go to different parts of the country to help out the children. So the last year, All India Ramanujan Maths Club has started another branch, that is National Council of Teachers Scientists. That is also one of the organizing committee of today's program. So thank you, Dr. Suresh Kumar from the Johnson Institute of Technology and Mr. Kannibaran from the Galileo Science Club. As far as the chief guest of today's is concerned, so I am very much privileged because I remember 4 or 5 years ago, I have gone through one of the book and I have even purchased one book, Fun with Maths, published by Vigyan Prashad. So I had gone through one of the book since I have purchased from the World Book Fair in Vigyan Prashad stall. So I found the book very interesting, and when I saw Sir is teaching the origami, then I happily accepted the invitation to join because I would love to see, because mathematics people when trained with the basics of mathematics with the help of origami will especially enlighten all the students who are facing the problems in understanding the mathematical concept. And since origami is one of the rare art that I think need to be taught from the beginning of the geometry that starts in class 6. So thank you, sir. I have gone through your book and I will be very happy to learn something from you today. So thank you all the team members, Kannivaran sir, Dr. Suresh Kumar, and a special thing to be SS Sastry sir. Thank you. Thank you very much.
Thank you, Dr. Rajesh Kumar Thakur, sir, for your valuable information, sir. Now I call upon Professor Sasi Kumar to introduce our respected chief guest.
Good afternoon. So if you say maths is boring, then you have to watch this seminar, the Maths in Papers. The chief guest of the day, Shri V. Shivashankara Sastry. He did his graduation in science and joined a bank, but his passion for mathematics and science, same with others was overwhelming. He is a mathematician, brilliant origami and Japanese paper artist, talented painter, cartoonist, avid fossil collector, amateur astronomer, author of 14 books for children on making science and mathematics easy to understand, translated for 2 science activity books. While working with the project for Sarva Shiksha Abhiyan, Sastry reputation spread, and he was regularly holding demonstration for students and teachers on origami as a mean of making maths fun and easy to understand. Over the past 4 decades, he has been presented more than 800 math workshops throughout the country. Also, many teachers whom Sastry coached in origami for mathematics began to win prize for math modeling. Sastry says all his skills in origami were self-taught, and it's evolved from his efforts to find a solution to problems he had faced at various points in his life. V. Shivashankara Sastry was awarded winner in science communication. Also, he received a state award for outstanding efforts in science communication. His name has been imprinted on the Limca Book of Records for the largest jointly made origami structure of the rocket, 5 feet 7 inch tall in the year 2010. The instruction to the participants, it's going to be an interactive session. So participants are asked to have 5 A4 sheets, pencil and a scissor. Now I hand over the session to the chief guest. Thank you, sir.
So shall we start?
Yeah, sir. Yes, sir.
Okay. So mathematics through origami is in the cards, since 40 to 45 years. But nobody has done, a kind of a connection between the pages of the curriculum as well as to the origami models. That means to say, for example, if there is a theorem in the textbook, there must be something, in origami. There must be a construction, in the pages of the NCERT book. There must be something, in origami. That kind of a correspondence, if you were to do, then only, origami will be adopted straight away in the curriculum. All my efforts, in these 40 years has been, in that direction. So first I identify what are the kind of a difficult concepts which people, face, in learning mathematics. So then, I will find out, something or the other in origami, and also see that, these both things are corresponded, together. Both things are connected together. Okay, first of all, I will just start this session by proving a theorem. Pythagoras theorem is the most important and also, popular theorem, because it is the first theorem which is taught, in the primary school. It starts from the 7th standard itself or 8th standard itself. So there are various proofs of Pythagoras theorem, but the thing is that it is quite lost, in the mumble jumble. The basic things, what the teachers, or the students do not understand about Pythagoras theorem is that, how is that these 3 numbers, let us say a square plus b square equal to c square, so they are just related. So the another kind of a thing, here is we are having, some most of the problems in geometry or in algebra, mixed up together. For example, a to the power of n plus b to the power of n equal to c to the power of n is the famous formula, which was not at all proved, and it proved, only, about a decade ago. So people, try to confuse, with that number theory problem was also the area of problem, in this Pythagoras theorem. That's why, I did, this kind of activity, to clarify, those things. Number one. Number two, for our children, there is nothing, they can do, in hand as far as mathematics is concerned. So that is another kind of a motivation to see that, something is done, by hand, kind of a hand activity. I must integrate, the mathematical concepts, or mathematical theorems, mathematical constructions, etc. With some kind of an activity. That's why that was another kind of a motivation, to do. Okay, straight away I'll come to the theorem. Pythagoras theorem, it is to says that in a right angle triangle, the square on the hypotenuse is equal to the square on the adjacent sides. Okay, let us see what can be done. So please have this paper. This is an A4 size paper. I have chosen this yellow paper because of the contrast which is here. So now you can see that what I do. You are able to see, sir? Hello? You are able to see the paper?
Yes, sir.
Yes, sir. Yes, sir.
Oh, yes,
Okay,
sir.
right,
Yes, sir.
right.
Yes, sir.
That's right. That's right. So I will hold the paper like this. This is an extra thing. I will hold it again and cut this out. This is exactly a square paper now. Exactly a square paper. This I will hold it like this. Then so it has got 4 leaves here. The first leaf I take, then hold it to the corner. There are 3 here. This 3 to the back. This appears to be a right angle triangle with a pocket here. See, there is a pocket. So put your finger in the pocket. So make it like this. Press it. It becomes a short square. So it has got 2 leaves here. So lift this up. Turn it over. Lift this up. Then open it. It becomes a boat. It becomes a boat. So this is an ordinary boat which every child does it. So what has to do with Pythagoras theorem? So let us see where the Pythagoras theorem lies here. So we should reverse the process. We have made a boat and these are the lines inside. So it looks like a grid, small squares, and also the diagonals to it. So let us enhance all these kind of diagonals. I am just marking the lines for the holes which are already there. I am not putting any extra line of my own. So these are the lines which are available there. Please watch. Only this much. I have not put anything extra. So now, for my convenience, I will choose this right angle triangle. So this is a right angle triangle ABC. In fact, there are so many right angle triangles here. You can choose any right angle triangle, but for my convenience, I have taken this much. So B is the right angle. So Pythagoras theorem says AC square is equal to AB square plus BC square. This is the relationship. AC square is equal to AB square plus BC square. So now on AB when you see, there is already a square, and BC there is already a square, and also upon AC there is a big square like this. Now how to measure the area? I will not use any scale. I will look to this AB square and it contains a diagonal and also this right angle triangle as well as this right angle triangle, which appear to be in a very equal. And also upon BC square, angle triangle, this is a right angle triangle. This area of the square triangles, this right angle triangle, this square contains another two right angle triangles. So I will mark them. This is 1, 2, this is 3 and 4. Now we are having on square AB two right angle triangles, on square BC two right angle triangles. Says this has to be added together. When we add together, 2 plus 2 becomes 4. Whether it contains this AC square upon AC contains 4. Yes, it does. Look here, 1, 2, 3, 4. So that's why the square upon AB, square upon BC, when we add together, it will be equal to in area and square upon AC, 1, 2, 3, 4. That's how Pythagoras theorem can be proved for practical purposes in a school atmosphere. In fact, children will be very happy to do this. To do this into a boat like this, a boat they do. Making a boat is very easy and children enjoy this. Once you show that in a boat there is Pythagoras theorem, they will definitely go for it. In fact, nobody instructs them in India how to make a boat. That is not in the curriculum. But the thing is, once you show that there is Pythagoras theorem, whenever they make a boat, they will see the Pythagoras theorem inside. So now I may also draw your attention. This triangle ABC, what I have chosen, is an ideal triangle in the sense AB is equal to BC. So actually this one becomes not a scaling triangle as such. It becomes isosceles right angle triangle. What about the scaling triangle? Definitely we can do that. On the back of it, there is space. So by just drawing one line like this, you will have a scaling triangle. I have used the same. Here also on BC there is a square. So on AB, see there is a square. There is a square. And also on AC also there is a square. So when you just count this Pythagoras theorem as before. So I called this demonstrates my approach to origami and as well as mathematics. So mathematics and origami are combined together here. I take a origami model and then open it, and inside that I will see the mathematics in the curriculum. So now I will go to the next model. Take another paper like this. The same Pythagoras theorem I will prove in a very different way, because usually 3 square plus 4 square equal to 5 square is the Pythagorean triplet, which everybody knows. So how to illustrate this Pythagorean triplet? So this idea or this concept, make 3 square plus 4 square equal to 5 square, so that people will come to know that it is the area. So we shall hold this entire A4 size paper into a square like this. Don't cut this portion, just fold it like this. Open it, then make it like this. See, I am not cutting this portion. So fold it once, again twice, and also another time. When you open it, you will see 8 divisions. 8 vertical divisions. So we shall repeat the things foldings in horizontal way. These are 8 divisions. Fold it like this. Once, this is second time. This is third time. So I have folded the A4 size paper into a square. I have not cut any portion and hold it 3 times vertically and also horizontally. What you get is a grid like this. So we shall make all the lines in the grid. You can observe this contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 plus something plus this area. So this area has to be ignored. Now it becomes a grid like this. We have folded the paper and these are the lines for the holdings. No extra line I have put. Now I will remember this, that the 3 square plus equal to 5 square. This is the first Pythagorean triplet. So 3 square means and breadth to be equal. See, I will take this 3 here, 3 here. Also cut it out. It's my portion 3 into 3. Next is 4 into 4. Next is 4 square, 4 into 4. So I will take this. This is 4 into 4. Next is 5 into 5. 1, 2, 3, 4, 5. So this is 3 square, 3 square, 4 square and 5 square. 3 square, 4 square and 5 squares. So let us see all put together what happens. So this is 3 square. This is 4 square. This is 5 square. It will be exactly a right angle triangle. It's a right angle here. In fact, children can count the 9 plus the 16 is equal to 25. So this illustrates them how to get Pythagorean triplet, and also the area exactly it contains 9 squares. Here it contains 16 squares. 5 squares means an exact 25 squares. That's why Pythagorean triple 4 square, 5 square can be by paper holding. Now I will take another paper. So I will go to some angles, how it is possible to teach some angles. I'll hold it like this. And take away this portion. This is this square. Hold it in half. What you get is a straight line here. Go to the right corner. Bring it over here. This is the right corner. Bring it to the central line. You should touch the central line here. Later, hold it like this. Then hold it like this. If you remember, this is the rocket which we used to do. Like this, we used to do. This is a rocket which everybody does it. So open it and see the lines. So these are the lines. Looks like a geometrical construction. So O, A, B, C, D, E, and G. It looks like a geometry. What we have made is a rocket. Now we shall see angles. For example, this angle, this one, this one, this one, this one. We will not use any protractor. Immediately something is visible. This is diagonals. They cut at right angles. So this is 90 degrees, no doubt. We have not used any protractor. So what about this angle G? Totally for a square, this angle is 90. It is exactly half of it. So it must be 45. Now we are having two angles ready. This is 45. This is 90. What about this angle? Actually, this angle is the external angle for the triangle FG and also this O. So external angle is equal to sum of the interior opposite angles, 45 degrees plus this angle. Then what is this angle? Again here, totally it is 90. It has been divided into 1, 2, 3, 4, 5, 6 equal parts. So 90 divided by 6 is 15. So this is 15 degrees. Naturally, another one is also 15. This is also 15. 15. It's all 15 degrees. To tell you what is this angle. For a triangle is equal to interior opposite angles, 15 plus 45. That is 60. What about this angle? 60 plus 15, 75. This angle we already know. We shall verify whether it is correct. 15 plus 75, 90. So 90 plus 15, 105, 120. See how many angles we have got. We have almost got a kind of a protractor. All through one rocket. So not only that, how many types of triangles are there? For example, OFG, what type of a triangle? Then OF and also C, what is the type of a triangle? Then ODA, what is the type of triangle? There are 7 types of triangles you can teach: acute angle triangle, obtuse angle triangle, right angle isosceles triangle, equilateral triangle. There are 4 isosceles triangles, etc. Not only that, you can also create some kind of a puzzle. Let us say you hold it somewhere here. We get a line. This is a line we get. Call it as XYZ. We can also ask what is this angle. You can also create puzzle and ask. Then they have to start from here, put all these things. Then 105, they have to come. Then opposite thing is 105. And then this they have to calculate 75. This has 75. Then corresponding angles. Then they have to say it is 75 degrees. So all in a rocket. Once you tell the child to do the rocket, it will be very easy for them to do the rocket. In fact, it is a kind of a plaything in origami. In fact, they will shoot like this. So inside that you get all these kind of a concepts, and once you show them that these kind of things are possible, definitely they will be very, very happy, because not only that kind of a rocket they do, they every time they go on saying these angles, these triangles, etc. So in origami we do something also more. After doing this, this is the origami model which need not be done. Rocket is the easiest one, but how to convert it into something else. This becomes a peacock. So this is what I wanted to just tell you. I have shown geometrical construction. I have proved a Pythagoras theorem, and also I have illustrated 3 square plus 4 square 5 square how to get it here. So next I will go to on a solid, how it can be done only through this one. So I will do a solid or tetrahedron. So again, so the geometrical solids are very difficult to understand. In fact, it's such a kind of a difficulty is there that people do not teach them at all. Now we shall see what can be done with the A4 size paper. Here you can see the straight line here. Here it is broken line. Here you can see the straight line. In fact, I will mark it if you want. So it becomes like this. 1, 2, 3, 4 triangles. Similar thing I will do it here. Now I have these two models. So I will hold this and then this. Put one inside the other. So this is tetrahedron. So we can verify in Euler's formula E plus V equal to F plus 2, here number of vertices, number of faces, number of edges. We can free that formula also. So I have shown you now a solid, Pythagoras theorem, a geometrical construction, and also I will show you something else. Algebraic identity. This A plus B whole square is the first identity we teach for the children. This is the first algebraic identity we teach. People are always asking me that what is the use of this, where we use this, in our daily life. So where we used, this kind of identity a lot, and then found, something astounding, and share with you that kind of a thing. The square, I will third of it is equal to this length. This is the drawing you have seen everywhere. In every textbook, for A plus B whole square, this is there. If this is A, this is B, then this is A square, this is B square, this is AB, and also AB. That is the explanation given for the identity A plus B whole square. This is A square, B square, AB, and also AB. Now where it is used? In fact, traditionally we have been using to create the image of Buddha. I will show you how. Now these are separate. This is A square, B square, AB, and AB. See what happens here. Is it not a sitting figure of Gautam Buddha? In fact, even today, when sitting posture of Gautam Buddha is done using this, they don't call it as A plus B whole square. They say Buddha figure is always done using 9 squares. This is 1, 4, 2 plus 2. These are the things I wanted to. You feel it. I want your comments.
Sir, as a mathematics faculty like me, you are inspired more, sir. You are inspiring more, sir.
No, what's the point? The point is that I am relating, this ordinary paper cutting and also paper folding to directly into identities, to Pythagorean theorem, to geometrical construction, etc. So that is the point. In fact, I do 3 days program, on mathematics through origami, including quadratic equations, including cubic equations. I just demonstrate, using the paper, like this. In fact, Vigyan Prasad has sent me, to more than 800 places, since 40 years to teach, mathematics through origami.
Great, sir. So some question from students, sir.
Definitely, yes.
Sir, learning geometry through origami was interesting. What made you to see origami in mathematics?
Okay, there is an interesting story, for it. See, there was one book was published, in 1895 in Chennai, Madras. 1895, mind you. Okay, that book was from T. Sundara Rao. T. Sundara Rao was the author. T. Sundara Rao T. Sundara Rao was a deputy commissioner, assistant deputy commissioner, of Chennai. When he got retired, he went to your own store called Spencer's. That was the foreign goods, foreign stores. He wanted to purchase a gift item for his own grandson's birthday. So he went there, and he tells me, he tells him in the introduction, gift packet number 4. See, in those days in 1895, there was no word called, origami, paper folding, etc. So gift packet, perhaps it was a origami book. So he bought it, and grandson, for this gift man, he began to see those himself. So because he was in that 8th forum math days, so things he wrote a wonderful geometrical constructions for the in the world. The paper holding and also integrated took place in Chennai in 1895. So translated to Germany by about 1900. So people, from American Mathematical Society noticed it in German publication. They retranslated German publication into English and they published it. American Mathematical Society has published it 47 times. But nobody knows in India about Sundar Rao, as well as geometrical constructions in paper holding. So when I found this kind of a thing, this kind of a marriage, this kind of a geometry and also geometry, algebra, etc., or mathematics being married into origami took place in India. So definitely it is our heritage. So it made me very close to me in my heart that to find out this. But there was one difficulty. Even in the programs conducted by Vigyan Prasad, people used to show these origami models, straight line, triangle, that, this, etc. That's all. But what I tried to do was, the curriculum mathematics is the only mathematics they are exposed to students and as well as children. So I have to relate page after page the curriculum mathematics and also this origami. That's what I try to do. In fact, people when they attend my workshop, they are astounded to find this cubic equations, quadratic equations that can be achieved in paper. So what I tried to do was that. That's how that people wanted to know, and I became very famous.
Wonderful, sir. Thank you. Sir, another question, sir. Sir, you told that origami is not in the curriculum. So can you throw some light to the staff and students to learn origami of their own? Can you suggest a book or a material?
Nowadays, internet is the great leveler. Anything and everything you find in the YouTube and also in the internet. In fact, just you tap YouTube origami, and you will get more than 250,000 videos in that. Go to that and straight into. Nowadays, children do not read books. That is a fact. Go to the YouTube, this, and go on doing it. This kind of in mathematics, finding mathematics, you require some training. So that for about 1 day. So then definitely you can go into that and find out yourself.
Thank you, sir.
Okay. Is it all?
Yes, sir.
Okay. Thank you very much. Thank you very much for being attentive and knowing these things. In fact, I'll be happy to conduct a workshop if there is a very good audience. If you could organize. In fact, after this COVID, etc., if things were to be freer, I can come out to your place, and do the things. In fact, I'm a regular visitor to Chennai. In fact, there's Periyar Science Center. They call me regularly, to do the workshops, there.
Okay, sir. Sure, sir. Sure, sir. We are very much eager to see in your institution, sir. Soon you will see, sir.
Okay, thank you very much.
Okay,
So,
thank
goodbye.
you. It's a yeah, sir.
Goodbye. Shall I close it?
Thank you, sir. Okay, sir. It's a really wonderful session, sir. Thank you for the wonderful presentation, sir. Now I welcome Shri Kannabaran, sir. Sir, a few words for us, sir. Kannabaran, sir.
Yes, sir. Yes, sir. Sir, thank you, Shri Sastry, sir. It's my privilege to propose a vote of thanks on this occasion. First of all, we extend our heartfelt thanks to our today's chief guest of the second day webinar series. It's very interesting. Shri VSS Sastry ji, sir, who carried out today's session. It's an enlightened manner. Sir, he enthusiastically demonstrated the simplest method of learning mathematics, paper-based activities. I know him very well. I attend so many programs. Thank you very much, sir, for today's wonderful session. Then I personally thank Mr. Rajesh Tagurji, who presented the felicitation address for today's session. Then I extend our heartily thanks to the management and principal of Johnson Institute of Technology, who is successful organizing this webinar series in collaboration with Galileo Science Club. And I thank to all the IT team, especially Suresh sir and Murali sir, and their team for his kind support. So once again, I thank all the participants, those who are participated in today's webinar series. Thank you all once again. With these warm words and kind messages, see you all tomorrow again in another valuable session. Have a good day. Thank you, sir.
Thank you, Kannabaran, sir. Thank you very much. Now I invite Ms. Divyanjali, first year artificial intelligence student from Johnson's, to propose a vote of thanks.
Chairman, Principal Sir, and Head of the Department, faculty members, and participants. I thank to our Honorable Chief Guest, Shri Shivashankar Sastry Sir, as Communicator in Karnataka. It is a great topic which we have received from our Honorable Chief Guest. Really, we thank you, sir, for your valuable work and origami and formulas. And also, I thank for our Johnson Institution of Technology, Coimbatore, and Kanabiran sir, Galileo Science Club. A special thanks to our Rajesh Thakur sir, Secretary Club. Thank you for our administrator, principal. Thank you for all participants. Thank you for giving me this opportunity.
Thank you very much, sir. Thank you, Sastry, sir. Thank you very much. Okay, sir. Thank you.
Galileo Science Club Udumalpet is affiliated to Vidyan Prasar. Vidyan Prasar is an autonomous organization under the Department of Science and Technology, Government of India. From the last 10 years, to improve the science and science-related researchers, the Galileo Science Club is organizing many programs in our state Tamil Nadu. Particularly for the school students, in last 8 years, to improve the technical science among the students, the club conducted lots of programs. For National Science Day, the club conducted programs like student discussion with scientists, science activities, and science competitions. A famous Indian scientist are invited for the programs and the student are allowed to discuss with the scientist. The Galileo Science Club also conducting many celestial objects regarding programs for students and also for public in public places too. In that, to point, Transiting Venus 2012, Ison Comet 2014, Transist of Mercury 2017, Angular Solar Eclipse 2019, Prenominal Solar Eclipse 2019-20, Partial Solar Eclipse 2020. These programs are conducted through telescope in public places. The club have been conducted scientific workshop on the topics such as simple science experiments and model rockets. Night sky watching programs are conducted through various places in Tamil Nadu. In Scientist Birthday, science regarding seminars, disorder management awareness, conserving nature and conserving wildlife programs are conducted for National Environmental Day. To celebrate this day, nature walk programs are also arranged for school students and teachers. To encourage the scientific way of thinking among the students and teachers, the club conducting many webinars and seminars. To encourage and develop the hill peoples, skywatching programs are conducted in their native places. In Corona crucial lockdown period, on behalf of Galileo Science Club, the relief items are distributed for hill peoples, specially challenged peoples, and for transgenders. In the time of Kaja storm, on behalf of Galileo Science Club, relief items were distributed to a village in Tiruvarur district. The team also taken many students for science trip for the places like ISRO, Kavalur to encourage the scientific way of thinking among the students. In the crucial Corona lockdown period, the Galileo Science Club conducting many webinars for students and teachers. In that particularly, to develop the interest in the Department of Astronomy, many webinars are conducting. All of you are invited to get benefit by attending. Johnson's College of Technology and Galileo Science Club joined together and organized many programs in state level. In that, disaster management and amateur radio workshop are notable. In the last year 2019, to organize the angular solar eclipse, the Johnson's College of Technology were supported to their level best. The Galileo Science Club were very happy to join once again with Johnson's College of Technology in this webinar. We conveying our hearty thanks for Johnson's College of Technology and the coordinator Dr. Suresh Kumar sir.